Welcome to smiklearn. Today we are going to see a new concept, that is the OOPS concept for the beginners. OOPS is nothing but it's an object oriented programming concept. We'll see a list of OOPS concept here. First is we'll see what is class, and second is object, and then we have number 3 data encapsulation, and number 4 is data abstraction. Number 5 is inheritance, number 6 is polymorphism, number 7 is dynamic binding. So first we will see what is class. A class is nothing but is used to define the data and function inside in it. That means a class is actually they will say it's a blueprint of an object. Okay. So a class is for defining the data as well as the member functions for an object. Okay. So this is actually a skeletal of the object. So we call it as class. Then a class is actually a concept called bottom-up approach. This is the programming style we are using here is called bottom-up approach. Previously we used in C programming and all, they called as top-down approach. Top-down approach in the sense, first we have to declare the variable, and then we have to write the logic inside that, and then we'll print the report, print the result. That's how the top-down approach is. But using the class, we have to define the logic first, and then in the main program we have to call that class, we have to create an object, and then we have to print the result. So this is called as bottom-up approach. First we have to define the logic, so that is called as bottom-up approach. So a class is a real world objects that can be created. We can create a real world object using the class. That is the concept of a class. You can see here an example of a class. So you can see here class pin. I have declared a class name as pin with open bracket, and I have defined the data and properties below. For the pen class, you know a pen is an object, right? So for that pen, we have different properties. That is ink color, pen width, pen height, and then pen type. It can be a ballpoint pen or any pen. So that is string type, pen type. So these three variables are called as data members or member data. We can call it anyhow. Okay, data members or member data, or otherwise they are called as properties. Properties of an object. Okay. So each object will have its own properties. Okay, that's the properties we have to define inside the class. And then we have the methods or the functions. Using these properties, we can do writing. We can draw. Okay, using the pen we can do writing, we can draw. So these are the methods of the function I have defined here. So this is called as a class. Based on this class, we can create any number of objects. So we can create a real world object using this class. And another example I can say, we have an animal, a bird, a plant. Okay. So animal means it can be any animal. So you can say animal type, and then we can have different properties like animal type, and then animal name is a buffalo or a cow. And then animal type means it can be a domestic, it can be wild animals, like that. We can define the properties of an animal, and then we can write the functions. So what it will do, it can do running, it can jump, like that. We can do the activities. So the member functions or methods we call it as activities. Okay. So we can define a class like this in the OOPS concept. This is one of the concept of the object oriented programming. So next we will see what is objects. Objects are nothing but it is the instance. We call it as instance or a variable of a class. So based on the previous, we have seen the class name pen, right? For that pen, we can create any number of objects. So using that objects only, we can call the functions. We can call the data from the outside world. Okay. So that is the use of objects. So we can create objects. This is one of the concept of object oriented programming. So we can create objects using the class. Any number of objects can be created. For example, we said no, class pen can have any number of objects. It can be a Rotamac pen, it can be a ballpoint pen, it can be a ink pen, it can be a red color pen, it can be a blue writing pen. Like that we can define any number of objects. Then these objects can only access the data and functions of a class. Using these objects only we can call the functions which is defined inside the class, right? So that functions we can call using the objects only. So they are called as they are called as physical and logical. Okay, so objects are physical and logical. Physical in the sense you can see a pen is an object, right? That is physical. Logical means using that pen what all we can do. We can do writing, scribbling, drawing. So these are called as logical activities. So we call this as object. This is second concept. And then we have the example here for the object. So in the previous example we created a class pen. Based on that we can create any number of objects. So in the example I have shown you a class pen. Okay, we defined it previously. Using that pen I have created here different objects called Rotamac, ballpoint, ink pen, gel pen. So pen is a class. For the pen class I have created nearly about 4 objects. So we can create any number of objects using this class. Okay, and then using the class we can call the function Rotamac.writing, Rotamac.drawing, ballpen.writing. Like that we can call the different functions inside the class using the objects. Okay, so this is the example of an object. This is another concept in OOPS concept. Next we will come to data encapsulation. A data encapsulation is nothing but it actually in the previous example we have seen the data and function, the data members and member function inside a class. So this is called as, this concept is called as data encapsulation. That is encapsulating both data and a function inside a class. We call this concept as data encapsulation. Both data members and member function inside a class, this concept is called encapsulation. Another concept we can see here is data hiding. Data is hidden inside here. Inside the class, what are the data members we have defined that can be hidden by using the scope of a variable. That is called as, if you declare a private, then that data will be hidden. If you make it as a public, that will be available in real world object. So we can define the data scope by using private or public keyword. Okay, so, so the data can be cannot be accessed actually outside the world because this is private. If you declare it as a private, you cannot access the data outside the world. So that is called as data protection or data hiding. This is another concept in the OOPS. So data cancellation, data hiding, data protection, all these are concept of OOPS. And then we have the data abstraction. Abstraction in the sense a class of a pen can have different types of properties. It can be a pen type, pen name, pen like this we can have different properties. But we are not going to use all the properties of a class, right, of an object. We can have only important properties. We can call only important properties of an object. So for example, if you take as a chair or a table, so it has different types of properties, right? Table length, table width, table height, table breadth. So like this we have different properties, but we are not going to use all the properties inside the class. We are going to use the important properties of a class. Okay, that important properties concept is called as data abstraction. Abstraction in the sense we can abstract the data, we can reduce the size, reduce the data which are not going to use. We can avoid that data. Okay, we are going to use only the important properties, essential information of the class. And then we come to inheritance. Inheritance. This is the fifth concept here. Inheritance is nothing but a class can be inherited or derived from another class. That is called as parent-child relationship. A parent class and we can have another child class. So both the class can be created a relationship. What is the usage of creating a relationship means a parent, a child can access the parent parent functions. So we can create a relationship between the parent and child here using this inheritance. We can see different levels of inheritance like a simple and hierarchical, multiple, multi-level, hybrid. So there are different types of different levels of inheritance. Okay, and then we have the another concept, another usage of inheritance is called as code reusability. That is, code reusability means we don't want to touch the existing parent class. We can create any number of child classes. Based on that, the code can be reused. You can say reusability. Single inheritance. In this example, we will see how the single inheritance works. First, we have a parent class. The parent class has the pin class, and this has some of the data members as well as the member functions. So sometimes we need to add some more functions or some more data. We can add it into the parent class itself. Instead of that, we can extend the parent class to by creating another class using the child class. So instead of adding the data members and data function inside the parent class, we can create another class which can create a relationship between the parent and child. So here a child class has a pin child, and then I have added two more parameters, two more properties here, and then a scribbling is a function here. So this is the actually a single inheritance. Single inheritance in the sense a parent and a child, that's all. We have only two classes here, a parent class, a child class. So the child class can access all the data properties and functions of the parent class if you create an object based on the child class. Okay. So if you create an object for the child class, that object can access the parent class data properties and data functions from the child object. This is called as single inheritance. Only two classes, parent and child, that's all. And next we will see multi-level inheritance. Multi-level inheritance in the sense it has a parent class, and then we have a child class, and then we have the grandchild class. Like this, we can have a multi-level inheritance. Multi-level means a parent class and two or more child classes. So this is multi-level inheritance. Most probably, this does not support in Java and Python and all. And then we have the hierarchical inheritance. So parent class, we have a parent class, and then we can have the two child classes. So this is called as hierarchical inheritance. So the child class can access the parent, and another child class can also access the parent. So this is called as hierarchical inheritance. And then we have multiple inheritance. We have two parent classes with a one child class. So we can have two parent classes, that is with the connected with the child class. So this is the multiple inheritance. Okay. And then we have the hybrid inheritance, where the parent class will have two child classes. Again, these two child classes will link with the another child class. So this is called as hybrid inheritance. This is one type of inheritance which is allowed in the C++ or Java. Next concept we are going to see is polymorphism in OOPS concept. This is the very, very important concept in the OOPS concept. So a polymorphism can take many forms. Many forms means not forms, different types, different methods, different levels. So that is called as many forms. Polymorphism means many forms, many form type. Then it has the ability to take more than one form. It has the ability to take more than one form. That is, a function or operator can be overloaded. We can write the same function repeatedly. Okay, so that is called as polymorphism. That concept is called as polymorphism. And then we have the function overriding. We will see this concept here next. So here is a polymorphism example I have shown. I have created one class sum. That class sum has two methods here. One is int add. This is the int add is a method here. Then float add is a method here. Okay. So int add has two variable, int variable and int b, and float add has float a and float b. Okay. So this method can be overloaded like this using the different parameters or different return type. So this is called as function overloading. So I have created one sum class and then addition is the object. The addition dot add 5, 6. So this will call the first function, that is which is accepting only int a and int b. Second function will accept only 3.4 and 7.8. So that is for float value. So automatically the compiler can identify which method to call, for the int add and int a, b, then for float add, float a, b, which method to add, the compiler can understand. This is called as function overloading. So this is another concept in polymorphism. In upcoming session, we will see what is function overriding. Overriding is nothing but is another example of polymorphism concept. Overriding means a parent class will have the same class name, same function name, and the child class can have the same function name. Okay. So a parent class will have the same function name. A child class can have the same function name. A class A will have add function. Again, a class B will have same some function. So both the functions can be overridden. That is called as function overriding. A parent class will have same function name. A child class will have the same function name. So when you create an object for the child class, that can be overridden. Instead of calling the parent class, it will call the child class function. So that is called as function overriding, which I have not explained it here very clearly, but you should understand this is one of the concept of polymorphism. Next we will see what is dynamic binding. Dynamic binding is nothing but the objects are created only at the time of running the program. When you are running a program, when you are running a C++ Java program, the objects will be dynamically created. Dynamically created means using the class, using the objects and all, the compiler can understand, and the objects are created only during the run time. When you are running the program only, the objects will be created and memory space will be allocated for that particular object. Okay. So if we create two or more objects, each object will have its own memory space. So it has its own properties, each object will have its own properties, its own methods. If we create another object, that object can have its own properties and its own methods. So like this, each object will have its own properties and its own methods. So this is called as dynamic binding. Dynamic binding means the binding will be made. The binding will happen during run time. The objects are created during the run time. So this is called as dynamic binding. This is another concept of OOPS programming, OOPS concept. So finally, I would like to thank you for all the members who are joined and subscribed in the channel, and they are welcome to the program. So upcoming we can see many videos like this.